Alrighty, day 4, log properties today. Today we're going to go over the main log properties and we're going to do some exercise with log properties. Get stronger. So first one is the product property. If you have two logs with the same base, I'm going to work right to left here sort of. So right to left, if you have two logs with the same base here, let's see, go green, b, right? So the log of m base b plus the log of n base b, you can combine those into one log by taking the stuff and multiplying the stuff together. So you have the log of m times n. So the log of m plus the log of n, if they have the same base, you can make them into one log by multiplying the stuff. That's called the product property. So if you're adding two logs with the same base, you can make them into one log by multiplying the stuff. Quotient property, same concept. We have two logs with the same base. If we're subtracting two logs with the same base, you can combine them into one log by dividing the stuff. And you got to get the right stuff on top. So the first stuff, like if it's a log of m minus the log of n, the first stuff goes on top, and the second stuff that you're subtracting goes on the bottom of the fraction. Okay, then there's a power property that says if you have the log of something to a power, you can pull that power down and multiply it by the log of the stuff, the log of the base of that power. So the log of a to the p, that could be equal to p times the log of a. So that power property is pretty handy. And then this last one, the natural log. Remember the natural log? That's how you say this. You don't say ln x. You say natural log of x, and the natural log has a base of e. So really, the natural log is just like a regular old log, but it just has a different base. It has a base of e. That's all. So it's just like every other log, except for the base is different. Okay. So just a little follow-up on natural logs. If you have like the natural log of e to the fourth power, what's the base of the natural log? The base is e, right? So if the base is e, then when I write this in exponent form and I think about what the value of this is really asking e to what power is equal to e to the fourth. And so that value is just 4. Right? So the natural log, thing to remember there, has a base of e. Okay, so now let's put some of these properties to use. So let's do some exercise. Here we have 3 statements. The log of a equals 3, log of b equals -2, log of c equals -1. Got to be a little careful when we're doing these exercises because this is not saying that a is 3. It's not saying a is 3, it's saying the log of a is 3. So what we're going to do in this little exercise is we're going to break up a log of something into a bunch of its log parts using the properties. Okay, same thing with like log of b. Log of b is -2. It's not b is -2. It's not like you just take -2 and you put it in there for b. That's not what we're talking about. Okay, so you got to be a little careful there. That's what students usually tend to kind of make that mistake when they're working on this stuff. All right, so what can I do with the log of a times b? What property could I use to break those apart? Could use the product property. Okay, and the product property says if you have two logs with the same base and you're adding them, then you can multiply the stuff, or in reverse order, if you have the log of two things that are multiplied, you can break them apart and add them. So this would be the same as the log of a plus the log of b. And then now, just for like added little fun, we have these little values to substitute in. So the log of a is 3, so really this could be like 3 plus log of b, we said, is -2. And so that final answer there would be equal to 1. Right? But the main thing is just understanding the properties, understanding that the product property can break two things apart and add them. This next one over here is going to be the quotient property. So we can take the quotient, the log of some quotient, and split that apart and subtract the two logs separately. So this would be like the log of b minus the log of c. Hey, do you have to subtract things in a certain order, or can you flip them around? Does it matter what order you subtract?
Yes, it does.
Yeah, it does, right? They're not commutative, we say. So the subtraction, if you don't get the order right, you're going to be off by a negative sign. So make sure that the stuff on top is the stuff that you write first. And the stuff you're subtracting is the stuff that you write last. Log of b then is negative 2. So this would be, after our substitutions, negative 2 minus negative 1. Minus a negative is plus, so that would be equal to, I believe, negative 1, right? Because minus a negative is actually a plus. Okay, next one here is the power property. And the power property says that if we have the log of something to a power, we can take that exponent and actually multiply it by the log of the stuff. So this would be like 4 times the log of a. And our neat little log of a is 3, so that's really 4 times 3. And so the final answer in that one would be 12. The next one is kind of a combo problem, so we got multiple properties going on here. So in the top part, we have the log of a times b. So is that going to be plus or minus? Plus, right? So this could be the log of a plus the log of b. And I'm just going to put that in parentheses to separate it. And then on the bottom, since it's c on the bottom, I'm going to subtract the log of c. Log of a is going to be 3. Log of b is negative 2. Minus the log of c, which is what, negative 1? 3 plus negative 2 is 1, minus negative 1 is like plus 1 is going to be, I believe, 2. Okay. Whoa. Hello. Hey, what's going on? All right, same kind of thing here. You got to be a little careful because you got AC in the denominator. So this one is going to use both the product property and the quotient property. And so when I break this up, it'll be the log of b minus, and I'm going to put this in parentheses because they're both in the denominator, log of a plus log of c. You know, because log of a times c, you'd use the product and add them, but they're both in the denominator. So that means that this negative has to apply to both of those logs because they're both in the denominator. So really you're minusing them both, kind of. So the log of b is whatever that was. What is the log of b? Log of b is negative 2. So this is going to be negative 2 minus 3 plus negative 1. I think, if I remember that right. Negative 2 minus 2. Final answer, negative 4. Man, I'm boring today. I'm boring right now. This class is dead anyway. Right, Anna? Put her there. What about square root? What's the same as that? What power is that? 1/2. Do you agree, Kaylee? 1/2? Is he right? Okay, so this could be the same as what? The log of b to the 1/2 minus the log of a squared. And then I could use what property to get these exponents down? Power property. So then really this is like 1/2 times the log of b minus 2 times the log of a. Do you agree with that? Good. Now we're picking up the pace here. Let's go. Let's go. Let's pick up the pace. Log of b is whatever that was, -2. So this is like 1/2 times a -2. Bada bang, minus 2 times 3. That's going to be a -1 minus a 6. That's a -7. Anyone object? Okay. So that's kind of breaking up logs, taking the log of some stuff, and you can break it up into multiple logs. Usually we're going the other direction. Usually what we're doing is we're doing this type of thing where we're taking more than one log and we're bringing it into one. Because a lot of times we're solving equations with logs and we have like this log is something plus that log is something. You can make them equal and then you can combine it to make it into one log and solve an equation using those properties. So this is a little more practical, I think. Log of 3 plus the log of g, when they have the same base, I could use the product property and make that the log of 3 times g, or 3g. Right? Directions say write as one log simplified. Sometimes it simplifies all the way down to a number. Next one, this 2 is an exponent. If you have a 2 log d, that's the same as the log of d squared. Okay, minus 2 logs, that's going to divide. This is going to be the log of d squared over f. Down here we got some more natural logs. Natural logs have a base of what, Sydney?
I don't know.
E. Good. Yeah, E. Remember E. E is like pi. It's like 2.71. So we have the natural log has a base of E, so it's like right there. They don't write them in, though. Be nice if they wrote them in, but they don't write them in. Anyway, so we have the natural log of 6 minus the natural log of A minus the natural log of B. This one's kind of confusing. I'm going to think about it this way. I'm going to get rid of these parentheses, and I'm going to just distribute that negative through there. So really this is like minus the natural log of A, and it's really like plus the natural log of B. So I rewrite all that, and it's like the natural log of 6 minus the natural log of A plus the natural log of B. And so now I can kind of do these two first. And so the natural log of 6 minus the natural log of A is the natural log of 6 over A, like that. And then I have the other stuff plus the natural log of B. If I'm adding two logs at the same base, I can do what to their stuff? Use the product property and multiply. So I multiply those two together, and I'm going to end up with the natural log of 6 over A times B is going to be 6B over A. If you multiply, it ends up in the numerator like that. And then don't forget to put a little ka-chow under there. I talked to Dave. He said he was ka-chowing all of his answers now instead of putting boxes around them. Yeah. All right. Here we have a little bit of power property going on. And this might be a happy little problem. Let's just see what happens here. We have the log of, I'm going to change that to be 2 to the half power. So this is going to be 2 to the half power base 2. Plus, I'm going to take this 1/4 power, put it up there. I'll make that 2 to the 4th to the 1/4. What? 2 to the 4th to the 1/4. Power to a power, you do what to the powers? You do what to the exponents? You multiply the exponents. So 1/4 times 4 is actually just 1. So this is really, all said and done, the log of 2 to the first power. And so if we put those together using the properties, because that's what we've been doing, now we have the log of 2 to the half times 2 to the 1. That's going to be 2 to the, add those exponents, 2 to the 1. What's 1/2 plus 1? 3 halves, right? Okay. Because I take them together and I put them together and I multiply the 2 to the half times the 2 to the 1 But to multiply 2 to the half times 2 to the 1, I add the exponents because they have the same base. So it's going to be 2 to the 3 halves. Oh my gosh. And then now I'm going to take this because I can evaluate it. 2 to what power equals 2 to the 3 halves? 3 halves. So this one actually simplified all the way down to just be some number. Where these over here, some of them had variables and some of them up there had, yeah, they all had variables, I guess. How are we doing? Are you understanding it? No one's piping up. So either you're just kind of like taking it in a little bit and you're maybe, or you're getting it all, or you're just writing it down. You should pipe up. Come on, pipe up if you're confused. Don't be shy. Yep. Yep. Yeah, I can slow. The request was to slow down a little bit. I'm going kind of fast today. There's a lot to do. Sorry. All right, few more problems and slower. You should have told me to slow down a long time ago. Then we wouldn't have went so fast. So now, no, just kidding. That's rude. Oh my God. What's the base when the base isn't there? 10, right? So all these have the same base, don't they? They're just not written in there because we don't write the common log base in. And so what do you do if you add all these logs at the same base? Because we want to simplify and write as one log or one rational number. Use the product property so we can combine these. We could kind of do everything at once because they're all adding. So you could take all the stuffs and you could multiply all the stuffs together and make it one log. So that would be like the log of 4 times 5 is 20 times 3 is 60. Now that's not a happy little log problem, is it? You don't know what 10 to what power is 60. Do you know that? It's going to be like between 1 and 2, isn't it? So it'll be like 1 point something. I don't know. So we can just leave the answer as just that 1 log is 60. Okay. The next one, 3 log of 2, 3 times the log of 2 base half minus 2 times the log of 4 base half. What do you notice that you could do here? Put the exponents back. Yeah, we can try that. So let's put those exponents back. So really that's 2 to the third, and this is 4 squared. All right, let's do that, and let's brush it off a little bit. Let's clean it up a little. So this is really, instead of the log of, or 3 times the log of 2, we're going to say that's the log of 8. 2 cubed, which is 8. And I'm going to write my base 1/2 as a fraction. Minus, over here, I'm going to write this as a log of 4 squared, which is a log of 16 base 1/2. Now, I could combine those logs, couldn't I? Because they have the same base. So if I'm subtracting, I would do what? Divide or multiply? Divide. So I'm going to make one log. I'm going to make it into one log of 8 over 16 base 1/2. Wait a minute. 8 over 16. That's silly. That's just 1/2. So really, oh, wait a minute. This is turning into some happy little problem. The log of 1/2 base 1/2? Huh. That's just 1, isn't it? Yeah. Because 1/2, this is, remember, this is like saying 1/2 to what power equals 1/2. Right? If you change the log of 1/2 base 1/2 into exponential, it's like saying the log of what, or the 1/2 to what power equals 1/2. So that's 1. And the last one has some natural logs. We also have some more powers that we can put back. So exponents we can put back. We can put that 3 back and make that 3 cubed. So that really is the natural log of 27. Whoa. Let's do a boxy 27. Plus the natural log of 2. Can't do anything with that. minus this 1/2 can go back. What is 1/2 the same as? 1/2 power, square root. So really this is a square root of 9, which is 3. You know, because 9 to the half power is the same as the square root of 9. Same thing. Anyhow, so now what? Starting from left to right. The natural log of 27 plus the natural log of 2, I can combine those to make the natural log of 54. And then I'm going to subtract the natural log of 3. And then I can take that and I can do a quotient property, the natural log of 54 thirds. Which 54 thirds can even be reduced a little bit further, can't it? How many 3's go into 54? 18. Ka-chow! Yeah, so today we're just exercising these log properties, and then where we're eventually going with this is we're going to use them then when we're solving equations to, like, you know, combine things down to one log or subtract logs to both sides, stuff like that. All right, good job. Just a quick little shout out to Ratatat Nat today for going to the next level and making the AP world real. All right, and to Aaron for APing it up, and then Carissa is also going top dog AP style. And are we missing anyone else for AP? Oh, you're AP too? And Anna, she's AP too. I had one AP class, so I'm also part of the AP brotherhood, sisterhood. What did you call it? Squad. Squad, yeah. Yeah, it's a pretentious squad. All right. Ka-chow.